Hello everyone, myself Rudruda Patil, subject chemistry, BSc Potsdam. My topic is molecular velocity and energy distribution in the gases. Introduction. Gases consist of large number of molecules. These molecules are in continuous random motion. Kinetic theory of gases explains molecular motion using velocity and energy concepts. Molecular speed are not the same for all molecules. Molecular velocity meaning. Molecular velocity refers to the speed with gas molecular move. At any temperature, molecular possesses a wide range of velocities. To describe this motion, three types of velocities are defined. Definition: velocity passed by the maximum number of molecules at a given temperature. Explanation: represented by the peak of Maxwell-Boltzmann curve. Indicates the speed most commonly observed among the molecules. Average velocity: the simple mathematical average of all the speed of molecules. Definition: arithmetic mean of velocities of all gas molecules. Explanation: calculated by the ending all molecular speed and dividing by number of molecules. Greater than most probable velocity. Root mean square velocity. This is a special type of average needed to calculate energy because kinetic energy depend on velocity squared. We square the velocities first, average them and then take the square root. Definition: square root of the mean square of velocity of molecules. Explanation: directly related to kinetic energy of molecules. Distribution of energy among molecules. Because molecules have different speed, they also have different kinetic energy. K is equal to 1 by 2 mu square. Analogy: think of the wealth in the country. Not everyone has the same amount of money. A few people are very poor, a few are rich, and the vast majority are somewhere in the middle income range. The Maxwell-Boltzmann distribution curve. A graph you should show in your seminar. So this it tells you that any given temperature, very few molecular have almost zero energy. Very few molecular have incredibly high energy. Most molecular have an intermediate amount of energy. If you increase the temperature, the whole curve shifts, meaning more molecules get higher energy. All gas molecules do not possess the same kinetic energy. Energy distribution is explained by Maxwell-Boltzmann law. At a given temperature, few molecules have very low energy. Maximum molecules have moderate energy. Few molecules have very high energy. Maxwell-Boltzmann distribution curve. X-axis molecular speed divided by energy. Y-axis number of molecules. Curve is asymmetrical. Peak represents most probable speed. With increase in temperature, curve flattens peak speed towards right. Law of equiparations of energy. Statement: total energy of system is equally distributed among its degrees of freedom. Energy per degree of freedom 1 divided by 2 kT per molecule. Explanation: applies to gases is thermal equilibrium, valid meaning at ordinary temperature. Use degrees of freedom. Definition: number of independent ways a molecule can store energy. Types: translation, motion among x, y, z axis. Rotational, rotation about axis. Vibration of amounts in molecule. Example of equiparations of energy. Monatomic gas. Degree of freedom 3. Energy 3 divided by 2 kT. Diatomic gas O2N2. Degrees of freedom 5. Energy is equal to 5 divided by 2 kT. Applications: explain internal energy of gases. helps in understanding specific heat of gases used in kinetic theory of thermodynamics. Conclusion: gas molecules move with different velocities. RMS, average, and most probable velocities describe molecular motion. Energy distribution follows statistical laws. Equipotension law explains energy sharing with molecules.